Alright, this is lesson 2.5 of our Precalc 12 class. Unit 2 is called Polynomial Functions. Lesson 5 is called Polynomial Theorems. What we're going to learn in this lesson is a couple theorems about polynomials. One's called the factor theorem and one's called the remainder theorem. Alright, and this general idea is kind of one big idea that gives us two theorems. So if we take some function p of x and we divide it by some polynomial function p of x and we divide it by some factor x minus a, the a value is some integer like x minus 2. P of a would equal 0. So let's unpack what that looks like a little bit. If I take this function, f of x, and it equals this 4-term polynomial, if I want to see if x minus 1 is a factor, then I'm going to take the a value will be 1. I'm going to evaluate f of 1. So I'm just going to take 1, the a value, and plug it in for all the x's and calculate. Well, if I do that, it would be f of 1 equals 1 to the power of 3 minus 4 times 1 squared minus 37 times 1 plus 40. And if you do those calculations, that does equal 0. So according to this theorem, the factor theorem, if p of a equals 0, where a comes from x minus a, a factor, I said that funny. If x minus a if you take the a value and plug it into the function and equals 0, then x minus a is a factor. So going back here, since f of 1 equals 0, then x minus 1 is a factor of our polynomial. Yes. We could try 4 more examples. So x minus 4, if we plug in the a value would be 4 into the polynomial. We'd have f of 4, which we can evaluate. And then, so yeah, you plug in 4 for all the x's. Notice that the second term is 4 times 4 squared, which would be the same as 4 cubed, 4 to the power of 3. So when I'm doing my calculations here, I can already see these two terms will cancel out. And we're left with negative 37 times 4 plus 40. I know that this is a bigger negative. This is a negative bigger than 40. So I know it's not going to equal 0. Then you could put it in a calculator and double check. Yeah. But since f of 4 does not equal 0, then that means x minus 4 is not a function, or sorry, not a factor of this function. So x plus 1, if we follow the format x minus a, we could think of this as x minus negative 1. So in this case, the a value would be negative 1. Or, just do the opposite of the operation here. So if I wanted to see if x plus 1 was a factor of the polynomial, I'm going to evaluate f of negative 1. When you plug in negative 1 and you calculate it, we see that we get an answer that's not equal to 0. So this is so x plus 1 is not a factor of this polynomial. And we could keep going. If we have x minus 8, we would plug in 8 into the function, we would get 0. So x minus 8 would also be a factor of this polynomial. And then the last one, x plus 5, the a value would be negative 5. So we plug in negative 5 into our function, and we would, I don't know, you could probably do that in your head. If you're dealt the math homework, it just depends on it. I might just plug it into a calculator, just to make sure you don't make a calculation error and then get the question wrong. But it does equal 0, so x plus 5 is a factor. So so we know there's a degree of 3, so there's potentially 3 factors, and we found all 3 of them, x minus 1, x minus 8, and x plus 5. Notice what we didn't have to do is we didn't have to do any division. We didn't have to do any long division or synthetic or even any box method division. So the factor theorem can be very useful in saving us time. Okay, one more thing to note, the three numbers that were the factors, where did they go? 1, 8, and negative 5. What's 1 times 8 times 5? It's 40. Hint, hint, wink, wink. Okay, let's see here. Okay, so the remainder theorem is the other theorem, and it uses the same idea. If you take a function p of x and you divide it by some factor x minus a, you plug in a into the function p of a. If it doesn't equal 0, whatever number it equals, that is your remainder. So if we try dividing by x minus 2, and we evaluate p of 2, let's say the answer is 7. Well, the remainder would be 7 right here. So let's take a look at an example of that. If I take this function f of x and I divide it by x plus 7, the a value is negative 7, and I'm going to evaluate f of negative 7. So I'll plug in negative 7 for x, do our calculations. It doesn't equal 0, so I know x plus 7 is not a factor. However, it does equal negative 310. So when I take our polynomial and I divide it by x plus 7, I'm going to get a new polynomial, and I'm going to have a remainder of negative 310. Similarly, in the h function, if I divide it by x minus 4, our a value is positive 4. H of positive 4, if we calculate that, it gives us 446. So if I took our h function and divided it by x minus 4, we would have a remainder of 446. Okay, now I'm going to ask this question in a novel way. If we take a function f of x, notice the k value in there. We take this function and we divide it by x minus 3. The remainder would be 43. So what would be the value of x? So we're saying if we take the factor theorem, or the remainder theorem, and we plug in 3 for x, f of 3 should equal 43. So here's our starting point. F of 3 should equal 43. So we could take the x values and replace them with 3. And so that equation equals to 43. And what that does is it leaves us an equation with just k. K is the only variable once we plug in 3 for x. Which means we have an equation with one variable, we can solve for that variable. So we're going to evaluate 3 times 3 to the power of 3. That's going to be 81. And then we have 3k added to that, and we're subtracting 8. Well, 81 minus 8 is 73, so we can collect like terms. And then we can subtract 73 from each side, leaving us with 3k equals negative 30. Well, if 3k equals negative 30, divide each side by 3, we get negative 30 divided by 3 is negative 10. We have k would be negative 10. So that would be our answer. And what it means is that if we put in a negative 10 in the original function for k, then f of x, when divided by x minus 3, would have a remainder of 43. So it's a novel way of setting up or asking you a question about the remainder theorem, but it's not that difficult. If they asked the question a different way, and they said the exact same function with a k value in there, and they said it's divided by x minus 3, or if they said x minus 3 is a factor, what would be the value of k? Well, if x minus 3 is a factor, then we put 0 here instead of 43, as in f of 3 would be 0. But there's a remainder, so it's not a factor. Okay, some takeaways. We've talked about factor theorem and remainder theorem, which is really one calculation. And so hopefully you can practice calculating those in this lesson and and get comfortable with finding roots using these theorems. And hopefully this gives you some more confidence working with polynomials, polynomial division, and understanding what's going on. And I'm sorry I couldn't be there today. My kid's homesick, and so I'm trying to help my wife take care of my boys. And Leanne, you bet your buttons, I went to the Willow View Farms. I didn't go till yesterday, and I did drink some apple cider, and it was delicious. So thank you.